Well, hello from Canada. Today we're going to be taking one io.Reader and making it into many io.Readers, and in the process we hope to learn quite a bit about io.Reader. We're also going to do a bit more practice with channels because it turns out I couldn't avoid them. I am Matt from storyfeed.com and you're about to watch a video. Let's get started, shall we? So the basic principle is I want to take one IO reader and then have two IO readers that are functionally the same as the first IO reader. Turned out to be a lot more complicated than I expected. I've done a practice run of this. I didn't think that I'd need to use channels, but there was some reasons that I did. So when I first started making this, I made it so it didn't have any channels. And I even tried it with no mutexes, but then I thought, actually, if you're sending a reader to something, that doesn't know. If you're sending your reader to two different places, they don't know that that reader is going to have locking issues. And so I'd better make sure that it is read safe to both of those places that you're going to send the IO readers to. So functionally, what I just want to have is I want to have a function that takes one IO reader and a number and returns many IO readers. That's all I'm going for. I've created a directory here. It's currently empty. And into this directory I am going to put some Go files. So here we go. Splitter.go. Okay. First things first, this isn't actually a main package, so we'll call this... What's the name of the folder we're working in? IO splitter. Package IO splitter. Okay. So now we can get rid of our main function and start with our thing. Split n. Seems like a reasonable name, right? So we'll take an io.Reader and then we'll take an n, which is the number of readers we're going to get back. Oh, and obviously we're going to return a slice of io.Reader. That's a good start. Obviously we're going to need a type that actually is our io.Reader. So type split reader. No one needs to know what this is. I mean, we're returning an IO reader thing, so we can keep this kind of on the down low. It's a struct though, and currently I'm not completely sure what it's going to hold, but I know I'm going to need that type. Because I said I'm going to need to use some channels, I think what I'm going to do, and what worked last time, was I'm going to have a channel for a function which loops through the reader and sends the data in the reader through a channel. The reason I want to do this through a channel is to provide a level of protection. Yeah, so let's get this func. Let's go on it. Go func. Oh, we don't get to call it, but this will be read direct from input io.Reader and send out on channel. So that's the basic purpose of this. I feel like that probably makes it vaguely clear what we're aiming for. So we need an output channel of our reader's data. So we'll just put it in a for like this for now. And we'll need a slice. I'm just going to make that at the beginning, the buffer. So debuff, direct buffer. That can be a byte slice, and for now we'll just make it a 1000 big. This isn't perfect. But we'll just do it this way for now. So you go, we got a byte slice and we can use that for our buffer, and all we're going to do is we're going to loop on the reader and send the data out on the channel which we need and needs to exist already. So r out equals make chan. So we're going to make a channel, and this channel needs to be this needs to be able to do one of two things, I think. It needs to be able to include an error or the actual byte data. So we'll make a type for that. Type r out ch struct, and this has d, which is a slice of byte. Of course, remember, when you send a slice, you're sending actually just a pointer, so you wouldn't actually be chucking all of that data on the channel. And you're sending, and I'm going to make error as possibility as well, and that's an error. Errors are, of course, an interface, but I'm mostly just going to send whatever error I get from the reader down the channel at any point. So let's r out ch. So we've got this route channel, and then what we're going to do is we're just going to read n, comma, this should be fine actually, n. I was going to deal with something with the n, but I'm not going to do anything with that right now. N, comma, error equals r.read, and of course we need to send it debuff. So a reader, so an IO reader takes a buffer into which it will write the data. Again, a slice is a pointer, so you don't need to send a pointer to a slice. If you send it a slice, it has access to the data and it can change what's in that slice. So we send it debuff, and that will fill up. The results that come back are n, which is an integer, the number of bytes that it's actually filled, and an error, which is, well, error. And then we will just write that to the channel and call that a day for now. So we will put that on r out, and we will send that a new r out. Oh, it's not, this isn't a channel, this is a struct. So route t, just for type, the what's coming out of an r out. This probably isn't the best way of naming it, but it's the read out type, and this will be data, and that's a, and that will of course be debuff, but we're going to slice it, and this will wait until that has come out. Oh, this feels a little bit risky actually. Debuff, because even if someone else has read the data, there's a possibility that we will come around again. And that was why I needed an input channel to tell me to make the requests. Yeah, that makes sense. I did have an input channel before, and so I'm going to need an rin channel as well. And I think that'll just take a number. I'll get to y in a minute. rin equals make chan int. And then we can just range through this, right? We can for n equals range on rin. Okay, so that's the reader in. So debuff, let's not make it big just yet actually, because there are things we can do here. Debuff equals make a byte channel, byte slice. The number I'm taking in is actually, so if len debuff, tell you what, let's declare this as a variable and not actually fill it. Var debuff wiggle dash byte. Then over here, if length of debuff is less than or equal to n, not equal to n, then we will make a new buffer. And we'll make it the right length. So we will go debuff equals make on a byte byte slice, and that will be n big. Okay. So now we have our slice that we're going to put in our buffer, and now we're always waiting for a request before we send anything back. What we send back will of course be dependent on, it's got the buffer, and we'll send it an error of error. We don't need to send an n, and actually I think how we'll handle the n is we'll just slice this. So we go to n. Now I always get a little bit confused about this, but if I understand this correctly, n is the number of bytes we've read, but the bytes start at 0, and the n on this is not inclusive, so we will get all of the bytes up to n. We'll go through that channel, and that's our redirect function for now. Oh yeah, that should work because the error will go with it. If there's no error, it won't end. And if there is an error, we're still going to send the data. So that's pretty cool. Our RIN channel is an int, so it's just requesting a certain number of bytes of data. I think that just gets, so that converts our reader into a channel in a function form. Oh, you know what? I do want to have one other thing. If error does not equal nil, return. That makes sense. So, well, we should probably even close the channel there. It's not that important that we close the channel, I suppose. So let's, because once a channel gets forgotten about, it falls off the heap anyway. So we'll just return at that point, and the error will be the close. The next function we're going to use is going to keep track of all of the positions involved, how far each of the new readers are through the data, and so we can possibly lose some data if we, you know, I don't know how long these reads will be. Sometimes they might be super duper long, so I do want to make it possible that you can have multiple readers and you're not going to keep clogging up with lots of data. So I want to be able to drop some data off the front or slice things down just for efficiency's sake. Let's try this. Go func. This function, let's just leave it in here. This will need access to the in and the out. Let's start a for loop because I know we're going to be looping in this function forever. And this function will take a request from the reader and safely return and safely fill its bytes. I think we can do that safely. And then, so we'll do a data copy. So the things we're going to listen to, we're going to have to listen for our reader channel, and that's our out. So for select, now select statements are a little bit weird, but they have this really cool feature. Hang on, where's my 13? Line 30, there's a problem. Go function must be started, yeah. thing I always forget when I'm writing these, and this go function must also be started. So select statements can listen for multiple channels and just act on the first one they get. And if you use a default, that means they just don't do anything. So we'll just go in there and wait for a channel. And if you have a default, it says I couldn't get anything from any of the channels, so I'm not going to wait, I'm just going to leave. I do want it to wait, so we are going to wait for at least R out. Case ro colon equals read on R out, stick a colon on, and in this case what we want to do is we want to extend our actual buffer, which we don't have yet. Let's make a big buffer. Buff colon equals it's byte buffer. We'll make it empty for now. In the case that we get something, I want to append that data to this buffer. So I'm just going to do it the easy way. Buff equals append buff with ro dot, and let's see. R out should be a channel of R. Oh, change the type there. With that changing to R out T, that probably will make this work. Yeah, there we go. Oh, I see. It's ro dot. Not completely sure why that's not being able to guess it. Let's close the bracket there. Ro dot, and I think it was data anyway. And if that's worked correctly, then we have some data sent through our out. We're just gonna throw it on the buffer, but we're not gonna request new stuff immediately because I only want to request the next one a bit later. The other case we have is doesn't actually exist yet, but we're gonna listen for a read request from our split readers, and they need an ID. You know what? I think they need a channel, and that channel needs to take, we'll call it SP in, I think. Type SP in T, and that's a struct, and this definitely needs an ID. And I think it needs a return channel. But I'm going to worry about that in a minute. We need this split reader to take a channel of a spin. So our function will obviously need to return some split readers for I colon equals 0 semicolon I is less than n semicolon I plus plus. Usual thing. Let's come up with a result. Res colon equals slice of io.Reader, and I'm making a slice of io.Reader, not a slice of split reader. But res equals append, and res is just the word I always use for result. We're going to append the res to and just add the split reader SP that was what it was called, wasn't it, as a split reader, and its ID will be I, and its channel will be We don't have that channel yet, so let's create a channel. Spin colon equals make chan spin t. Okay, so this channel of spin t type, that's basically the request information, and I'm locking it to an ID so that the reader this function. The thing I haven't explained is I'm planning on doing this using closures. Maybe that was obvious already. So this function basically acts as the store for all of the core information. It gets thrown on the heap, so that should be okay. And we'll just use spin here. And then when we return res, we now have a slice of IO readers to handle. And where's a missing comma? 52. Line 52. Missing it's a missing colon in the literal. Okay. Func. And this one will work on a split reader. We'll call it SP, and this should probably work on a pointer to a split reader. Oh, and if that's the case, we should probably return a pointer to a split. We should append this a pointer to a split reader, and this function needs a name, and that function name must be read, right? And it's got to take a slice b slice of byte, and it's got to return an int and an error. That's the definition of a reader. If we don't fulfill that interface, we are not able to treat this as a reader and send it to the user. It can't be used in that sense. So it must have this function, and this function will first make that request on the channel. And send that data in, and then it will wait for its response, I guess. So sp.ch, is that right? Yeah, we can resend to that our read request. Now we have that spin t, so at the very least our spin t needs an ID. I'm going to send the byte buffer as well. B byte slice, that'll be filled, and I don't think we're going to send anything else in that case. So we need to make a new spin t and a spin t that had two. That first b will be b, and the ID will be sp.id. Then of course we need to listen. Oh, and it needed a channel. It needs to send a channel to listen for the response, doesn't it? So ch, and this one will be make chan why don't we just take the that same type again, the out, it's got the int and error, right? Our out t, so we, oh no, because that's actually got the bytes. No, I do need a, let's have an sp out. Type sp out. I can't type. Sp out t, and that's a struct. And this one needs a number, n, int, error. So that means our reader can still return whatever error comes up from the initial reader at some point during this challenge. So, oh, that's probably what it's complaining about down here. Make chan spout t. Oh, we should probably make that before that. So, make chan spout t, and then we will send ch here. Because now we need to listen on ch, so we'll go res colon equals sp listen to ch, and then we should probably do some, I don't think there's any actual checks we need to do right now. There might be in a minute, but for now we're just going to return wiggle dash, no, return res dot n res dot error. Oop. Okay. So if this has worked properly, we have our reader which just makes a request and sends that through the channel. In here, we now need to listen for that request. So the channel already exists, doesn't it? sp.ch. We had to put that in our results, which was called spin. Spin is here, so we need to listen to spin. Case equals listening to spin, and first thing we need to do is, if we have enough data, there's actually no need in calling the reader to get more data, is there? And this is one of the reasons that I'm doing it this way, is when I did it without having any collision detectant or any channels, the problem came up that it was possible for one channel to ask for data from the reader, and the reader would block. Now, I have no idea what the reader would do or why it would block, but a reader can block. And at that point, if this one is far ahead of all of the others and another reader comes in, well, if someone else has got a lock on it, they just can't get any data at all, even though there is a lot of data that's available that's been read already. But because you've got to use locks on the outside, or if you had to use locks on the outside, which was my original plan, then that would actually stop you being able to do this, and using channels kind of fixed this problem. I'm kind of frustrated because it's nowhere near as pretty, and it's not the kind of boring, straightforward code that I'm used to seeing when I write Golang. So this has been quite a challenge writing this, and I'm not completely certain it's super useful. This was entirely a learning exercise, understanding channels, but primarily for understanding the Go reader. So hopefully you guys can learn something from this and consider other options or potential for this. Let's carry on. So we've read in the spin, the reader request, the split request, and the SP is short for split, right? Maybe I should call it splin. Anyway, so we read in from the split, and we can get SP dot stuff, right? Let's see what we've got available. Oh, surely we've got that. Spin, listen to spin. Why can't it type that? Spin T. Yeah. So spin T has an int and a slice of bytes. Oh, and a buffer to put the data in. The int is the ID. Okay. So now we have a challenge of actually working out how far this particular split reader is through our data. Well, here I'm going to do this using I'm going to create another thing which is called pos, and that is a slice. Let's make a slice of int. Now this slice of int should be n long, n being the number of users taken as a function parameter at the very top here. So, and that will of course create it all zeroed, right? So now I can get the position that we are working with, which is p equals pos at id, which is sp.id. Then if p, well, let's just do the copy first, and let's assume that enough data's in. We've not necessarily proven that yet, but let's assume that the data's in. Basically, we just want to write into our buffer the data from where we're at in our position. So p copy. Now, copy is a built-in function that belongs, that's already in Golang. This is not io.copy, which can copy from a reader to a writer. This is just copy. It's very good for copying data of any kind. Just a super useful inside function for quickly getting data from one slice to another. So, the destination comes first. That is sp.b, perfect. And the destination, no, the source is of course our buffer. But we're going to start at p and then carry on as far as we've got. Now, you don't have to worry about this being too long. In fact, it's only going to copy what it can. So if either of them is longer than the other, then it will only copy from the length of the shorter one. So you don't have to worry about overflows or anything like this. So that should work. And then of course p and copy, I think, returns a number as well. I'm going to call it nc, which is short for num copied, equals this. So it'll just tell us how much data it copied from the one buffer to the other. That number of course is super useful, because then pos at sp.id plus equals p. So in theory now we read the data, and now we've incremented the position of this particular one, so if they come and read again, we now know where they're at, and we can read the next bit of data. The problem is, of course, that buffer is empty, and we never do anything to get that filled because we never make a request on that. So the next question is, how do we make that get bigger? Well, I only want to read from the reader, the input reader, if we don't have enough data to fill the buffer. So let's try it like this. If len buff is less than p plus len sp dot, I think it was just b, wasn't it? Yeah. If that is the case, then we need to make a request to the reader for more data. So we'll do that by sending by sending a read request. And that's right. The reason I didn't do that internally here but stuck it in another channel is I wanted this to be able to return and allow other functions to come in. So in this case we will do, and it was not the SP, we're working on the R in, and we're going to send something to R in, which is of course the number of bytes we want, which is of course this number, the p plus len sp.b minus len buff. Yep. And that's just, that will resolve to a certain number. Now there is a small problem here. We can actually end up with a weird blocking situation if two separate functions come in at the same time. Try and ask for this, they will block on each other and they will not get a chance to listen to the result. So we're going to have a our waiting equals false, and in here we'll put our waiting equals true, and we'll put an and here, and that way it won't make the request unless it has that unless it's got the result back from the channel. Hopefully that makes sense. So basically the our waiting, this is, we're waiting for the reader, so we are only waiting for the reader if we've sent something down that channel. So we're going to keep listening for this channel to send something back. If it sends something back, then we're not waiting for anything anymore, but we don't want to ask it for something if it's already making something. That's the theory here. So it does mean that we are going to return an empty result this time, because, and we know that for certain, but let's not worry about that. I'm just gonna allow it to return a 0 result for now. So in theory this will ask for more data from the reader. This one will get more data from the reader. This one listens for requests for data, and if it has a request for data, it makes sure it's got enough in its buffer. If it doesn't, now there's still of course the problem that this buffer will only grow, right? You're never going to get buff to shrink, and that means if you've got a lot of data. But for now I think this might be enough for us to start work on our tests. So let's tab edit splitter test.go, and in here func test basic, no, not test basic, test serial, and we'll take T, which is of course appointed to a testing.t because that's how tests work, and let's have a really long string of data. So pub data there, p data equals, oh, it's a slice of byte because that makes the most sense, doesn't it? Equals, and then we'll just byte slice a string so I can write it and test what it says. So let's write some really long boring sentence. We're going to use, for testing purposes, our reader will be a bytes buffer, okay? So there's a very simple thing. Initial reader r colon equals bytes dot new buffer, and this just returns the buffer you get is actually a reader and a writer. So I'm going to send it p data. So now we have a reader writer which has that. And here's the so if I do r dot and bring up the list of things you've got the bytes function, which is really helpful because you can just see all of the data that's inside it. It's got a cap, a grow, a read bytes, and if you keep going down, it's got the write option as well. So this is a read writer. You've got all of your data that you can quickly check. So this gives us what we need for testing this. So I'm going to now split it. RR. I tend to like to use a double letter to show that it's an array. It equals split n on r, and we're going to split it to 5. Okay. So in theory, RR should be a slice of bytes which has a length of 5. So let's just test that. If len RR is less than 5, return t dot error f, where are my readers? Okay. I'm not expecting this to fail. I can't imagine there's many cases where it will, but we put in that problem, and now I'm going to go over and test it. So here we are. I'm in the same folder. Go test dot dash dot dot, and it probably won't even compile, to be honest. No, it hasn't. I wasn't expecting that because, of course, I've only just been typing it up in front of you. So let's have a look. Splitter.go 6018 cannot use ro.d type byte as type byte in append. Oh, let's take a peek at that one. Splitter 60. That might explain some things, actually. It's a slice of bytes. Oh, that's fine. So of course we're actually appending bytes, right? Split.go to 68. I should probably clarify, because when you use append, you are actually appending, you're sending individual arguments kind of combined to an array if it receives a dot dot dot, and append receives this array unlimited length. So dot 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 says take this and treat it as all of the arguments but as a single array. So 68 cannot use spin type chan spin t as type spin t in the field value. Okay, that might be what the explanation, the confusion was earlier when I wasn't filling things in. So let's have a peek. Channel spin. So the split reader has a spin t. And this split reader's channel should be, oh, but spin should be a spin t, right? It's a channel of spin t type. And it definitely existed outside that function. So what's it complaining about? Cannot use spin type chan spin t as type spin t. Oh, the field on the object is not. That's where this should actually be a chan of spin t. So that explains that problem, and that's probably why when I tried to range over some stuff, it wasn't listening properly. Go line 75, unknown field ch in literal. Okay, 75. sp.ch. Yeah, it has that channel. ch split reader sp has a channel of spin t type. So as long as I send it a spin t, should be laughing, right? sp.ch is that? Oh, here's the problem. No. Line 36. So yeah, I'm trying to use that ch, which is spout. Yep. And that's what a spin t should contain. But I don't think I ever wrote that in the spin t. So ch, and that's a spout. And that's of course a channel of it. There we go. 58. NC declared and not used. Oh, we're down to the easy errors now. 58. NC. Oh, wrong thing. That was supposed to be NC. Okay. The test passed, but it was a really basic test. So now let's see if we can get the readers working. So, test serial. I'm just going to use io.copy and make a couple more buffers. So for I colon equals 0, semicolon, I is less than 5, semicolon I plus plus. Let's make buffs. Colon equals, and this is a slice of bytes. No, we're going to make it so that we've got the date, because a bytes buffer is actually a really nice struct type. You can initialize it empty, so we can do this. Make byte slice of bytes dot buffer, and it will make it 5 big. And in order, I'm just going to use io.copy, io.copy rr I destination first, res at I, rr at I, and in theory for I colon equals 0, semicolon I is less than 5, semicolon I plus plus. So this is a serial test, right? If actually I can just range on this. For underscore comma v colon equals range, we'll take k so that we get the errors. Equals range on res if v dot, I should get bytes as an option here. Yeah, if v dot bytes does not equal p, oh, p data, then of course we have a problem. T dot error f the unexpected read colon %d colon %s close quote, and of course what we're going to tell it is k and v dot byte. And that should be a complete test. This is a compile error, isn't it? 2315. That's fine. The copy takes a pointer receiver, or at least the bytes buffer works on pointer. So that should work here. Wrong one. And line 27, v.bytes does not equal slice can only be compared to nil. Oh yeah. Data bytes dot equal. And only if not. And there are problems. Yay, the more complicated problems. All Go routines are asleep. Oh, I know why that happened. The error wasn't passed. Yeah, I think we've basically ignored the error properly. So that's progress. So of course we've got to finish the first one, and all the others are going to wait. Let's try and see if we can follow the error out. So here, the error makes it out. And that'll actually end that and mean that it stops listening. But this doesn't know at this point to stop trying to look for more information. So we need to store an error here. Okay, error. There. Error. There. Error equals nil. Okay. And this result here gets an error, right? If ro dot error does not equal nil, then we need to set e equals ro dot error. And in here, we shouldn't start asking it for more data if we have an error already. Should we? Oh, it's a simpler problem than that. Okay, still, I do want to put an and on the error, and e is nil. If e is nil, then we can go in. I never returned anything here. So of course we take in sp dot, we have the channel, should receive a new sp out t, and the things we need to include are n, which is of course nc, and error, which is of course e. So if e is still nil, then that will work. Okay, let's try that. And now it's passed. Okay, so let's try and see. Oh, I need to take off this t-shirt. So if this is working properly, then all of our data here should actually, so we've just run through and we've said all of these are the same. I'm trying to work out how to make sure that this test fails. Can't think of a good example. Let's do that. Let's do that twice. I don't know. Copy. You know what? I don't even think this would make it fail. That's funny. Because of course it would just get the error immediately and stop. So that actually passes the test. But, you know, this was all about handling concurrency. Let's make a concurrent test. Yeah? Func test concur. And this needs to do a lot of the same stuff, for sure. Definitely needs to take a pointer to a testing.t. And what else does it need to do? It needs to have a bytes buffer. So reader equals bytes.new buffer, and that would take p data. Yep. And we'll split that. Let's have n splits equals equals. We'll make it 50. Let's have one that handles 50 different splits. I can't think why you would split a reader 50 different ways, but we can do it here. So let's colon equals make equals split n on r, and we use n split. So once we've done the split, for I colon equals 0 semicolon, well, let's make a channel. dchan colon equals 0 semicolon. No, make chan bool. Don't think I need much more than that. For I colon equals 0, I is less than n split I plus plus, and in this loop we want to actually start a go func. Oh, and these funcs, this is a weird thing, okay? When you do functions in a loop like this, the variable will change if you don't send it as a parameter. I think I need a reader and a writer. io.Reader io.Writer. We can do that. We need our reses, don't we? So res colon equals make slice of bytes.buffer, and this should be n split long, and when we call this function, our it should be writer than reader, shouldn't it? Everything's writer than reader in Golang. Writer, and then r, which is an io.Reader. Okay, and then here our writer will be res at I, and our reader will be rr at I. And then in here, what we're just going to do is io.copy from our into our writer from our reader, and that's all we need to do. And now they're actually quite big, and there's a function that it gives you which is called copy buffer, where you can send it a smaller buffer. So I'm just going to make a new byte buffer that's smaller, just to make sure that our bytes buffer gets used properly. I'm going to send it a small byte buffer, which is make slice, and we'll just make it 20 bytes. that may actually, in theory, that we're sending it a smaller byte buffer and making it work in 20 byte chunks, because we've not got that long a data string. And then dchan send true. Okay. And at the end, obviously, to close this up, we need to wait for all of them. So for I colon, no, for, yeah, it's up to, we're going to count to num splits, right? For I colon equals 0, I is less than n split, I plus plus. And then we're just going to listen. We don't even need to do underscore colon equals dchan. Once we've done that, we can test them all. So for underscore k, oh, let's just copy the other one. That's exactly the same. Okay, so just run through all of our results and make sure that they actually do contain the appropriate information. So we make a buffer, we split it 50 ways or n split ways. That channel is just for listening to the go func to finish, but basically we just try copying out of all 50 buffers into 50 other buffers. And then afterwards we check and see whether they've all done their thing. Let's see if that works. Test concurrent must be test concur. It's got to have the signature. Have I got the signature wrong? Oh, it should be a pointer. Fair enough. New problem. 45. Cannot use res type bytes.buffer as writer because again it takes a pointer. Copy buffer. So I need to use the and there. 49. No new variables on left side of colon equals. That's right. I don't even know whether I need this. I can probably just get rid of that and it'll work. And the test has passed, which is ridiculous. Can you think of any way of making this fail? It's definitely got the check on the end that all 50 of the results things should contain the buffer data. So what if I do res 20 dot, oh, it's, I don't think this is a writer, is it? Because it's right. Let's try that. That should at least make the test fail. Yeah, it's thrown a hello on the end and failed the test. So it seems to be, and if you look at that, it's clearly actually copied all of the data through. So as far as I can tell, this is a working reader splitter, but it doesn't do quite everything we want. But now we've got these tests, I can make some changes over here and add some safety that's going to help something. One of my concerns is that there are two Go routines that may never end. This one should end. If assuming the reader ends, this one will end. So maybe I don't need to worry about this one. But I do need to worry about this one, because I can't end as soon as I receive the error. I need to wait until everything is finished. So maybe I need to use like a done channel like I did before, and I'll just take a boolean done channel on here. Okay, done chan colon equals make chan bool, and every splitter will obviously need its done channel. And this is basically how we're going to end it, right? So make sure that function does end once all of the splitters have got their errors too. That done chan equals no, and that's just a chan bool. And once you've done that, so every time if res.error does not equal nil, then something has happened that has stopped us, and so we need to say we're done looking at this thing, right? So read sp.donechan, and we'll send that true. And so now we can listen to our donechan case dc colon equals to the donechan, and with this we also need a done number, don't we? Done colon equals 0. Done plus plus. If done is greater than or equal to n, then we can return. Now, with the two tests already written, that should mean that if I try and run this and the done thing doesn't work, 7317 DC declared and not used. 73. Oh yeah, don't need to listen to that. It's only listening for the number true. Ugh. All Go routines are asleep, so that means oh. I don't think I ever actually assigned that done channel, so it's a working channel that's empty. Because when I return the split reader, I need to actually give them a done channel. That's my mistake here. Comma donechan colon donechan. And it passes now. So that mistake was that if a channels work if you haven't assigned them, if you haven't made them, I think, or at least they will wait. But of course that means that they only exist for one person, and you kind of need to make them so you can share them. So that was the problem. It's kind of like this channel didn't exist. So that solves that problem. The only other problem is, of course, the constant growing that could happen. If we have a really long reading reader, then we've got to get rid of that. Not completely sure how to. No, we can do that. I'm going to make a new function. I'll do it at the bottom. I'm going to call it drop. Again, it's not going to be part of the public API. So drop. And this will take a slice of int, and we'll call that p. And it will take a slice of byte, and we'll call that b. And this is going to return a slice of bytes. Hopefully this will make sense in a second. So the slice of ints, of course, remember, when you receive a slice, you're not receiving, it's not quite a pointer, but it's a lot like a pointer. So as long as you don't make it longer or shorter, you're going to have the same data. Okay? So our drop function is going to go through that list for, oh, well, let's have a lowest, because we're going to look. We can only take away data off the beginning if everybody's read it. And so the lowest P is the least that has been read, right? This is the theory, at least. So lowest colon equals P at 0. for I colon equals 0, no, for I k comma v equals range p, if v equals 0, return b. So we're just going to return an unchanged slice. If v is less than lowest equals v. So now we know the lowest value for p in the slice. So once we've got our lowest value for p, we can reduce all of them in p by that amount. So for I equals range p, no, it's kv again. K colon equals range p, then p at k minus equals lowest, and the end result return b lowest colon. And so we're just going to slice off the beginning, and so our buffer can just drop off the beginning parts of the buffer. And again, we have the tests in place already, so I can try doing that drop wherever I think it fits and see if the program still works. Now I can put it here, but this will try and do the drop every single time someone does it. But if I put it down here, it will only do it whenever we try to get more data, and that feels like a reasonable place for me. So if we're about to get more data, then this should, then we can check and see if we can get rid of anything off the beginning before we add the extra data. It's a minor optimization, but it's, my concern is again for readers that read an awful lot of data, so much so that you just don't want to be storing it all temporarily, and you want to have lots of readers. If your readers are all coming at the same time, your multiple readers all being read at the same time, you still want them to be able to catch up and keep up. So that's the logic on why I want to be able to drop. If you've got, I don't know, megabytes, more than that, I don't know how much it would take before this is a problem, but that's why I'm doing this. Failed. K declared and not used, 104. Try again. And it passed the test. Took a little bit longer this time. I guess that's because, no, it didn't take much longer. So of course this is happening, there's some concurrency things going on, but basically that works. So I'm going to try and run through and explain everything I've done already. Hopefully this will be helpful. So since it's the easiest to explain, let's start at the drop function. I know it's not that important, but basically it just gets the lowest value for p, and cuts off that much from the byte buffer from the beginning, and reduces all of the p's by that amount, so that everybody drops by the same amount, and I can keep track of how far everybody is, all of the different readers are through the data. A split reader, this implements the read interface so that the split readers can be sent out in that slice of io.Readers, and of course they need to use a channel, so they just make a request down the channel with the bytes buffer they're using, an ID, which is just a number 0 to however many split there are, and the channel which we're going to send back the data, which is of spout t. We then listen on that channel, and if there's an error, then we are done, and we tell it it's done so that that function can finish. Because while channels don't leak, functions can leak. If you spawn Go routines and don't clean them up, they can leak. So this is to stop that from leaking. And then whatever we return, the results number and error. And here is our split m function, which is supposedly, this is the only important part of the public API that anyone needs to know about. We take a reader and we return a slice of readers. So public facing, this is good. I like that it's got a very small API, so anyone can just say, oh, this works like this. Send it a slice of readers, send it a reader, get a slice of readers, or as long as n. And this channel here, this function, go routine, will just keep running through trying to read data in its data buffer here, and so it calls the read function, and then it sends that data down the channel, and then it goes back to the beginning of the for loop where it waits to be requested for more data again. A couple of checks here for safety on size, but primarily it's just reading and then waiting to be asked for more data. The spin, spin, that's short for split in, the split reader input. So this is the channel we listen to the split reader asking for stuff. This function is definitely the most complicated function because this is the one that mediates the other two, the read methods, and the read methods from the split ones and the read method on the original reader. So it's definitely the hardest to read. It's got 3 separate cases. The done channel is the easiest in here. That's just waiting for all of the to say, yep, I'm done. Because once all of them are finished, this can return and the function is not left leaking, continually running or waiting to do something. The one where we listen for the data from the reader, yeah, we call the drop just to make sure we've got, that's not important, but it just does make sure that it doesn't grow too much. And here the buffered, we just add the buffer on the end, and if there's an error, if we get an error from the reader, then we know we don't need to read it anymore, right? So we're happy with that. And so we store that error in a variable that belongs to this function so that we can pass it back in our handle the request side of this, and send that back to everybody who's asking. The key bit of information where the data gets copied is in this small method here, where we just use a built-in function to copy the data from the buffer to the right amount and return how much data we've copied and whether there was an error. That's primarily what a reader does, these 2 functions here. The rest is just keeping track of our position. If you're wanting to write readers and writers, you'll probably find this function helpful. I just want to say thank you very much for watching. If you've made it this far, do feel free to like and subscribe. I hope I'll see you in the near future. This has been Matt from storyfeed.com, and you have just watched a video.